Hi everybody, welcome to a new Python tutorial. In the last tutorial we learned the difference between threads and processes and how we can use the built-in threading and multiprocessing modules. In this video we will go into more detail about a threading module, so we will quickly recap how we can create and start multiple threads. Then we will learn how we can share data between threads and how to use locks to prevent race conditions. We will also learn what is a daemon process and how we can use a queue for thread-safe data exchanges. So let's start and let's quickly recap from the last video how we create and start threads. So this is the code where we left off. So we say from threading import thread, and down here we define so we want 10 threads here. And now we create our threads, and for each thread we give them a target method. So this is the function that is then executed by this thread. And then for each thread we also have to say thread.start and also thread.join. So join means that we wait and block the main thread until the thread is complete. So yeah, this is how we can use the threading module. And now let's go into more detail and let's talk about how we can share data between threads. So since threads live in the same memory space, they have access to the same data. So this makes sharing data very easy. So we can, for example, just use a global variable here. So let's define a global variable, and in this case I will call this database value. And I will set this to 0 in the beginning. So this should simulate a database now. And now in our main code, what we will do is we will first of all print the start value. So we print our database value here, and then we will create 2 threads. So let's say thread 1 equals thread, and this will get a target method that we will call increase, and also a second thread, so thread 2. That does the same thing. And then for each thread we say thread start. And also thread join. So we wait for the threads to complete. So thread2.join. And at the end we print the end value. And then we again want to print the database value at the end. So, and now we have to define this increase method. So we say define increase. And here we want to get and modify our database value. So in order to modify the global variable, we have to say global database value. And now we can use it here. And now let's make some dummy code. So we want to simulate some database access. We want to get the value from the database and store it in a local copy. So we say local copy equals, and here we can simply copy it from our database value. And then we want to do some processing. So here we simply say local copy plus equals 1. So we want to increase it. And then we simulate that this processing should take some time. So we import time, and then we wait some time here. So we say time.sleep 0.1. And then when we are done, we want to write our new value back into our database. So we simply copy it back and say database value equals local copy. So this is our increase function. And now let's run this. So now we have 2 threads, and if we run this, or let's clear our console, let's run this again. So we see start value is 0 and end value is 1. So now you might be wondering, why is this 1? Because we have 2 threads, and both threads should increase our database value. So now the end value should actually be 2. And now, why is it 1? And this is because we have a race condition here. So a race condition happens when 2 or more threads try to modify the same variable at the same time. And now let's step through this code, what is happening here. So when we say thread1.start, then it will get the database value and store it in a local copy. So in the beginning this is 0, and then we will modify the local copy. So now our local copy is 1. And now, since we say time.sleep, our program can intelligently switch to the other thread and use the waiting time. So now it switches to thread number 2, and now thread number 2 invokes this increase method. So it also copies the database value in the local copy, and the database value is still 0 because we didn't write it back here. So now thread 2 also has a local copy which is 0, and then it increases it to 1. And then we again say time.sleep, so we can switch back to thread number 1. And now thread number 1 copies its local copy, that is 1, into our database, and then it's done. And then we are switched back to thread 2 again, and that now also copies its local copy, that is also 1 here, into the database value. So this is why the end value is 1. And now how can we prevent this? So for this we use the lock object. So we say from threading import lock, and then we create a lock here. So we say lock equals lock, and now we say our increase method gets a lock. So we have to give this here in the arguments. So we say args equals lock, and since this is a tuple with only 1 element, we also need a comma here. So Python needs this comma here in order to know that this should be a tuple. And also for our second thread, this will now get the lock as an argument. And now with a lock we can, so a lock prevents another thread to access this code part at the same time. So now we can say lock.acquire. So it basically has only two methods. So we say lock.acquire, and now we can process and modify the value, and at the end when we are done we say lock.release. So, and we should always, every time we acquire a lock, we always have to release it. So otherwise this will block and never release, so then we are stuck here. And now what is happening with this lock? So now let's run this and see if this works. Lock.acquire. So, oh sorry, this is a lock object. So now let's run this, and now we see that it's correct. Our end value is 2. So what happened here? So now our first thread got here, and since it locked the state, now it can modify the value, and it will not switch back to our thread number 2 here because the state is locked, so it continues and runs and copies the local copy that is now 1 into our database, and then it releases the lock. So now our second thread can enter this code part, so it also gets the database value, and this is now already 1, and then it modifies it to 2 and writes it back. So now this is working fine, and as I said, you should never forget to say lock.release. So there's a recommended way to use locks, and this is to use a lock as a context manager. So you can simply say with lock : and then use the part of the code here, and then we don't need to say lock.release. So let's also get rid of this. So if we run this, then we see this also works correctly. So this context manager acquires and releases the lock for you. So yeah, this is the concept of locks. And now let's talk about how we can use queues in Python. So queues are excellent for thread-safe and process-safe data exchanges and data processing in multi-threaded or multi-processing environments. And for this, we have to import the queue. So we say from queue import queue, and now let's get rid of this, and first let's have a look at how a queue is working. So a queue is a linear data structure that follows the FIFO, or first in, first out principle. So a good example of a queue is a queue of customers that are waiting in line, where the customer that came first is also served first. So let's create a queue object. So we say queue equals queue, and then we can put in some elements. So we say queue.put 1 and queue.put 2, and also let's put in a third object. So say queue.put 3, and now our code looks like this. So first the 1 enters our queue, then we put in the 2, and then we put in the 3, and here this is our front, so the beginning of the queue. So now if we want to get the first value, we can do this by saying first equals queue.get. So this will get and remove the first item. So if we print first, then this will print 1, and now our queue only has 3 and 2 inside. So this is how the queue principle is working, and there are a couple of other important methods. So first you can check if a queue is empty with queue.empty. So this will return true if the queue is empty. And then in a threading environment, whenever you get an object with queue.get and then you process this object, when you are done processing, you should always call queue.taskDone. So this now tells the program that we are done processing with this object and can continue. And there's also a queue.join method. So this blocks until all items in the queue have been gotten and processed. And this is similar to the thread.join method. So with this we block the main thread and wait until all the elements in our queue are processed. So these are the important methods you have to know. And now let's look at an example to how we can use this. So we say also we want to define a couple of threads, so we say num threads equals 10, and then we say for I in range num threads, and here we create our threads. So now we say thread equals thread, and as a target it needs to get a function, so we will define this in a second. And then we say thread.start, and we will also now use a daemon thread, so we say thread.daemon equals true, and I will explain what this will do in a second. So by default it is not a daemon thread. And then let's define our function. So our function, let's call them worker, and define this worker function up here. So we say def worker, and now we use an infinite loop, so we say while true, and then we say value equals q.get. so this will get two arguments, so this will get the q and also a lock, and here we will get the first value inside our queue with q.get, and then we will do some processing with it. So in this case we simply want to print the value, so we say print, and let's import the current, so let's say from threading import current thread, so we want to print this here. Now let's use an f string, so we can say we are in, and then we are in our current thread dot name, and in this thread we got the value, so we simply want to print this here, and then we are done. Remember, we have to say q.task done, and now what this is doing, this is an infinite loop that is now starting, and since we don't have values inside our queue, this queue_get method will block and wait until items are available. So now we wait here, so we have to fill our queue with elements, so we simply say for I in range, let's say 1 to 21, so we want to fill this with all the numbers from 1 to 20, and we say q.put I, and then at the end we have to say q.join, so we block the main thread and want to wait until all the items have been gotten and processed, and yeah, then we print end main. And now let's run this code and see what's happening here. And here we also have to, now this worker gets, oh, let's leave this lock and only give it a q, and now as arguments we have to give it in a tuple. Again we give it the q, and don't forget the comma here with one item. And now let's run this and see what's happening. And now we see that we have threads with different names from 1 to 10, so we have 10 different threads, and they get the values from our queue and can process the item here. And the order might not be sequential, but what is important here is that with a queue we can easily exchange the data in a thread-safe environment. So this value, this queue_get call is thread-safe, and also the queue_put calls are thread-safe, so no other thread can write at the same time into this queue position. And now let's run this again. So in this time we got lucky, and we got lucky again. So what might happen here is that multiple threads might try to print at the same time. So there might be print statements that are in the same line, so two statements in the same line and no line break. So to make it work correctly, we should say with lock and use a lock here. So let's also give this a lock. So let's say down here lock equals lock, and then as argument it also gets the lock, and now this should work fine and never produce confused lock statements. And yeah, let's have a look at what is happening here again and why we use a daemon thread. So our threads enter this infinite loop, and then it blocks here because we have no items inside our queue, and then as soon as items are available, then it can continue here and process the items. So in this case just prints it, and then after all the items are done, we can continue here. Then this will unblock, and then we will continue and print end main, and then we will leave the main thread. And now a daemon thread is a background thread that will die when the main thread dies. So you might be wondering, we have an infinite loop here. Why does our program correctly stop? So we say end main, and then it's done, and I can use my command line here again. So a daemon thread dies when the main thread dies. So if I reach this statement and then exit the main thread, then all the threads die, and so the worker method and the while true loop no longer gets invoked. And this is why we use a daemon thread here. So by default this is false, and if we don't use a daemon thread here, then our program will still continue here in our while true loop. So what we should do then is we should use another mechanism, for example some signaling mechanism like an event, to say that now we are done and we can exit the while true loop. So then we should have used here if some condition and then break. So yeah, and this is how we can use the queue. I hope you understood the concept of queues and locks, and if you have any questions, leave them in the comments. And yeah, I hope you enjoyed this tutorial, and see you in the next tutorial. And there I will go into more detail about how to use the multiprocessing module. So bye.